Hello, fellow Scratchers! Rotating platforms, spinning, turning, rolling platforms of pure joy, that's what they are. People may have been wowed at seeing Scratch games featuring moving platforms, but man, they will be simply blown away when they see these beauties. Indeed, by the end of this, episode 12 of our classic platformer series, I'm confident we'll all be having awesome fun creating the most amazing levels you have ever seen. Now you may have noticed that these awesome demo scenes I'm flashing up often feature more than one platform on the screen at once. If you've been following the series attentively, then you'll know that this is something we haven't been able to do easily before. But fear not, we'll be addressing that problem today too. Oh yes, this is going to be great. Now, just before we dive in, let's just whet your appetite. Did you know that when you stand on a rotating platform, the movement of the player follows a perfect orbit around the rotating platform's centre of rotation? Yeah, look at that! So just as moving platforms apply their movement to the player, so a rotating platform applies their rotation to a player. It's just going to take us a little more work to calculate the relative movement. But hey, that's what we're here to learn, so what are we waiting for? Let's get scratching! We begin where we left off in episode 11, and make sure we save a new copy, for this is episode 12. We'll start by trying to get two platforms on the same scene. For that we could do with a new scene with lots of empty space to play with. Click into the Level Sprite, and enter the costume editor. Here is scene 1, and I want to make a new passageway through to the left from here. Great. Now duplicate scene 1. Yeah, it's auto-named as Scene 6 for me, but since this wants to be to the left of Scene 1, drag it up above Scene 1 in the sprite ordering. Then I'll rename it to Scene 0. Hey, so who thought Scene 1 was the lowest you could go? No, not at all. We can even go negative without any problems, which can open up a lot of fun. Right, I need more space. I'll flip the level horizontally to match up with the entrance, and then shift over the walls to open everything up. Whoops, I need my left wall back. There we go. Let's just slap the green flag and check that out. Ah, splendid. Lots of space for movement. And since I fixed the wall jumping bug last week, I'm evidently trapped in this room, so we need these platforms. Click into the Platforms sprite. Cool. This is Costume 1, and it's our basic movement platform. We can use that. If you haven't already, then run over to Scene 0, stop the project, and click the Show button to make the platform sprite visible on the stage. I'll position it at the highest point I want it to move to. We'll be animating it down and then up from here in a loop. But first we must set the start position. Under the When I Receive Change Scene script, we need a new if block checking if the scene hash is the new scene 0. But we don't want this to be a door, so chuck that away. The previous scripts we used for animating a platform was the aptly named Animate Platform script, although I haven't been using this since we last changed our level around. Let's just see what that script was doing. Okay, so the way I left it, we had it starting at a given position, then animating through 3 different positions. So yeah, I'm going to change this to be a standard up and down movement for now. If you want to keep your existing animation, then just create a new custom block for this new platform animation and use that for this new platform instead. The first change we make is to set the starting position of the platform here, before we use the animating block. Go to XY, and it kindly puts in the current position of the platform for us. Haha, thanks Scratch. Now, the reason we do the go to before using this animate block is so each platform can start at a different position. Next, find the Define Animate Platform script again. Since we've already set the start position, we can get rid of the initial GoToXY block from in here. Now for the Glide To blocks. These need to move relative, that is a fixed amount away from the current position. The X positions can be simply replaced by the current X position. I just want these platforms to move up and down without any side-to-side movement. Oh, and look, we don't want this third glide and wait. This is just going to be a down and up movement now. Lastly, the Ys. We first move down by 90 pixels, so that's Y position subtract 90. Then to move back up 90 pixels, Y position plus 90. Sweet, that's nice and straightforward. Let's run that. Oh man, I forgot to show the sprite, didn't I? How many times do I do that? You've no idea. Drop a show block first thing in the animate platform script, and we'll try that again. Yes, now we are onto something. Nice to have a working platform in my game once more. But our biggest challenges still lie ahead. What we would like to do is drop in a second moving platform. Like this. And then just change the starting position to put it next to the existing one. But stop right there. This is not going to work, because this animate platform contains a forever loop. It's never going to finish running and proceed on to the next instruction. And hey, even if it did, we'd only be telling this same platform to animate up and down, not a new one. So nope, chuck that away. What we need is to use a clone of this platform to position and animate it independently of the first. And this is exactly what we did in the enemy sprite. So perhaps we can borrow some scripts from there. Just before we do though, scroll across to find some free space, ready for any enemy sprite scripts we might drag in. Now click into the enemy sprite. So to make use of clones, we have hidden the original enemy sprite. This is because the original sprite acts as a clone-making factory. The factory itself is hidden, but the clones that pop out of it are visible. Then we have this new when I receive about to change scene. The delete this clone within causes all the existing clones to be deleted. All except the original sprite, of course, as that is not a clone. Doing this before a scene changes sets everything up ready for a clean start. And here's the actual change scene event receiver. Now look, this is doing exactly what we want to do in the platform sprite. For any scene, we can have multiple spawn blocks, one for each enemy in a scene. The reason this is possible in this enemy sprite is that unlike in the platform sprite, these spawn blocks do not just animate the original sprite, but they position and then clone a new sprite. The downside of this is that the animation of each sprite cannot be controlled in the change scene script, but instead that gets done under a when I start as clone script over here. This is a tad more tricky, as we then need to find a way of knowing what kind of enemy or platform we are trying to animate. But yeah, we'll get around to that shortly. Okay, first, we need to copy some of the scripts from here into the platform sprite. Locate first the when flag clicked block, and we'll drag it carefully into the platform sprite. Next up, we want the when I receive about to change scene. And finally, find the define spawn type script. This will be useful for cloning the new platforms, so drag it into the platform sprite. Cool, these are the three scripts we needed. So click back into the platform sprite and, scratch, look at that pile of blocks. Come on, tidy them up. There we go, that's better. Now, I realise that as you've been working on your platformers, you most likely have lots of your own changes and scripts hanging around in here, but hopefully the changes we make here now will make enough sense that you'll be able to adapt your scripts to work in the same way as mine. First thing to do is replace the old door at and animate platform scripts in here with spawn blocks that create the clones. The first input is asking for the type of clone to create. This one is a door, but back in episode 8 we cleverly named the door costume as Key 1. Do you remember that? This simplifies the scripting. The X and Y positions come next. Copy these directly in also. Now direction. This is new to platforms, so just stuff in 90 so that the platform faces right. The door at script is responsible for animating the door. We should keep that for later, once we bring in the when I start as a clone hat block. Splendid! Next we do the same for the animate platform script. Copy over the position from the go-to block below. The costume? Well, check out the costumes. Oh yes, it was still named Costume 1. That's original. So if you haven't renamed it, pop that in as the first input. The direction can stay at 90. And then drag off the go-to and animate scripts for later. So far, so good. We just have one tweak to make. I've noticed that the define spawn script is not doing anything with the type input. Guess our enemy sprite doesn't either yet then. Anyhow, we need to be setting the costume to this value so that we can tell what sort of platform this is. Switch costume to, and drop in the type input variable. Now this will become a door or a platform before it is cloned. Great, so now to deal with these animating scripts. Like I said earlier, these want to be triggered under a new when I start as clone block. Bring in an if. And from the green operators category, contains. And what I suggest we do is use the costume name block on the left, and on the right, the word key. You see, this will now recognize any cloned platforms that is a door, since they will have the word key in them for sure. And therefore, we pop the door at script under there to handle the door animations. But you'll notice this door at block has its X and Y and costume inputs already set. But this new cloning strategy already has these details set up before the clone is created. So how about, for simplicity, we just pass through the current X position, Y position, and the costume name as it is, unchanged. This is getting a little bit messy. Let me just tidy this up. Right, remember these animating scripts never end? They are just forever loops after all, so we don't need to worry about using an if, else, or a stop this script here. Okay, if this isn't a door, then under here for me it has to be a platform, so I'll drop in the animate platform block right under there. If you have different animation scripts for different scenes, then you'll need to find a way to identify which script to run here. You can always check the scene hash variable or the costume name, or find any other way that works well for you. Let's give that a test. It's good to check that the platforms are appearing. Yep, there it is, phew, and that it also disappears off screen. Yep, good. And finally, I'm going to leg it all the way over to the right to ensure the door platform is also where I left it. Yes, you'll want to test each type of platform you've got in your game. Good, good, good. This is great news, because now we can finally try putting these clones to good use. How about we add in that second moving platform to scene 0? Find with me the when I receive change scene script. Here we go. Where scene is 0, let's duplicate the spawn block and modify the X position to be -86. That should be on the opposite side of the screen. And I'll also change the Y a little too. Okay, so if everything works as planned... Oh boy, yes, look at this. We finally have two moving platforms on the same screen. That's so cool, and opens up a lot more opportunity for really cool level design. We could even add back in some lava pools, doors, and platforms all on the same screen, right? Oh yeah! And man, that's really what this episode is all about. Opening up cool opportunities, because now we can finally look at introducing a new type of moving platform, the rotating platform. Yeah, this is what we've all been waiting for. Let's just start by experimenting a little. Click into the platform costumes and duplicate the existing costume 1, only I'll size it up into a rough square. This one is 86 by 86 pixels. Let's see how it looks on stage. Yeah, I like that. Having this rotating on the screen will look uber cool. Let's rename the costume as Square. Splendid. Now nip back into the code and we can change the costume used by just one of these newly spawned platforms to Square, matching our new costume's name and case precisely. So without any waiting around, we can check that out in-game. Hey, there it is. Nice. But enough of this up and down motion. Blah, everyone's doing that. The future is rotation. First, we need to decide how to tell the platform that it is a rotating platform. We could use the costume name, but to be honest, we'll also need to store the direction and speed of rotation. So what we can do is right-click the spawn block, and we'll edit its definition, adding in the new label turn, followed by an input named degrees. That will be how much we'll be turning the platform by each frame. Now each existing spawn block has the turn input set to the empty value by default, and that's perfect as a blank turn can indicate the platform is not rotating. But this square platform, I'll enter a turn of 1. Negative values will spin anti-clockwise and larger values spin faster. Just play around with this because it's super fun. So where's our define spawn script? Here we go. Make a new variable to store the spin value. Name it turn and make it for this sprite only. That's important, otherwise all the blocks will end up spinning just the same. Then right at the top we set the turn variable to the value of the degrees input variable. Okay guys, so now we have a way of identifying a rotating platform. Let's make it spin. Find the when I start as a clone script. The doors are identified by the costume name containing the word key, and everything else is up and down platforms. So we now want to check for rotating platforms. If turn is greater than the empty value, that's the same as saying turn is not the empty value, in which case this is a rotating platform. So first, set rotation style to all around, so that we can see it actually rotating. Then bring in a forever loop. In the loop, we turn sprite clockwise by and drop in the turn variable. Ta-da! Oh, whoops! We also need a show block. See, I always forget. And we wouldn't be seeing much at all. Let's give that a test. And there we go. A basic rotating platform. Very good. But there's nothing like a little physical interaction to test things out. And here we are, standing on the pinnacle of our achievement. And well, you know, something doesn't seem right. Do you see what it is? The problem is that the surface of the platform is just sliding past under our feet, and I'm not being carried along with it. The good news at least is that our wonderful collision fixing code is successfully pushing us out of the ground at each point. So if you didn't catch episode 8 for that, then now is a good time to do so. It will become even more important shortly. So the problem we have is that our existing moving platform code simply takes the movement of the entire platform and applies that to the player using the platform dx and platform dy variables. But for this rotating platform, now this is more problematic because the platform's position as a whole is not changing. Nope, it's just rotating. So if the platform turns by, say, 45 degrees clockwise, then if the player is positioned here, we need to move them to here. But if they were standing over here, then they need to be moved to here, and that's a completely different direction of movement. Welcome to the complex world of rotation maths. What is super awesome though, is that the movement of the player has nothing whatsoever to do with the size and shape of the platform being rotated. Be it a square, a circle, or a complex rotating maze, it matters not one bit. To know where we will rotate to, we start at the centre of rotation, that's here, find the direction and distance to the player, and then simply rotate that direction by the same 45 degrees. The distance stays the same, and ta-da, this is the new position of the player. As you can see, we could do this trick using a number of scratch readings, movements and rotations and position resets, but if you've been following my 3D raycasting tutorial recently, we have already covered some exciting rotation maths that can also solve this problem in a concise way. Let's look at it again. Here it is. So, simply put, given a position x and y relative to the centre of rotation and an angle of rotation, we'll name this CCW, standing for counterclockwise. Then the new position, x2, y2, is given by this beautiful yet slightly scary formula. If you do happen to understand this maths, then hats off to you. Some of you, though, may feel uncomfortable about using something that you don't fully understand. But let me just tell you, don't sweat it. In modern coding, we make use of countless software libraries that we don't need or even want to understand how they work. The important thing is that we know what they achieve and how to use them. So where do we start? Can we find the when I receive tick platforms? This script is where we record the movement of the platforms. You'll see it calls the tick block just below, and you can see it setting the platform dx and dy variables here. This deals only with platforms that are changing position, not rotating. So pull the whole script over to the side And so that we can handle different platform types, bring in an if-else block. Just return this little goToXY to the bottom of the tick block. That ensures that the platform's position is returned back to where it started before we did any collision detection. So again, we check if turn is greater than the blank value. This is a rotating platform. The else is therefore for the original moving platforms, so we can safely return those original scripts into there. Great, it's rotation time. Firstly, we must find out whether the player is actually standing on this rotating platform. We do this as simply as possible by moving the platform up by 4 pixels, change Y by 4, and check for a collision. If the platform is touching the player, then. Okay, now the tricky bit. You ready? Oh yes, a new custom block for the maths, I think. Call it Rotation Maths CCW. Remember, CCW stands for counterclockwise. And add a numeric input, also named CCW. Now, naming it like this is useful so that we remember the direction of rotation needs to be inverted. Run without screen refresh. And we are done. We can make use of the block before we code it up. If we are touching the player, do the rotation maths by rotating by, and remember to flip the direction, 0, subtract, turn. Okay, time to flesh out that define rotation maths script. To try to make this as simple as possible, let's split the maths up using many variables. We need a dx for this sprite only, dy for this sprite only, sin, sin, for this sprite only, and cos, you guessed it, for this sprite only. There, phew. Now we need the position of the player, but relative to the rotation center of the platform. Set dx to the player's x position, subtract the x position of this platform. And do the same for the dy, setting it to the player's y position, subtract the y position of the platform. Great, the next step is to notice that we use the sine and cos of CCW twice each. So to simplify the maths, we can pre-calculate these values. Set the variable sin to the operator sine of the input variable CCW, counterclockwise. Similarly, duplicate that and set cos to the cosine of CCW. Cool, and now in one swoop we will set platform dx and platform dy. So, after calculating the rotated position, we need to be left with just the change in position. To get that, we will simply end by subtracting dx, like that. Set the platform dy just the same, only subtracting dy. Okay, now follow these next steps carefully so as not to make a mistake. Bring in a subtract operator, and under that, an addition. Yep, one of each. Now we need 4 multiplications. Put them either side of the subtract blocks. On the far left, drop in 2 dx variables. And on the far right, 2 dy variables. Now for the cos variable. Carefully now, one goes in the top left and the other goes in the bottom right. And the sine variable to the top right and the other to the bottom left. I just love the pattern of this maths, it's so cool. Now we plug it all together. The right-hand block drops into the right-hand input. A quick tip, when dragging a rounded block into the input of another block, aim the top left corner of the dragged stack at the input rather than where your mouse pointer is. The top left corner is what matters. There, like that. Do the same for the dy multiplied by cos, and now bring in the left-hand multiples too, both of them. Great, well done. So now making sure to drag this by the middle, drop the minus stack into the set platform dx, and the addition stack into the set platform dy. Yay! Whoop whoop! This is a thing of beauty. And guys, I am just bursting to try this out because if everything has gone to plan, that really is all we needed. Okay, here we go. Oh yes, right away we can see a huge improvement in movement. Look at that. Now, something you can't see here is how important episode 8 has been to the success of these rotating platforms. The reason for this is, as we calculate the new position of the player after a rotation, it is almost certain that part of the player will end up colliding with the platform. This would be a disaster, except that in episode 8 we created the most wonderful script called Find Closest Space To. This script runs right after the moving platform changes the player's position, and as such it searches out the closest spot nearby where the player is no longer colliding, and moves us to there. This little fix is an absolute lifesaver, and we don't even see it happening here. But without it, boom, this would just all fall apart. So yay! Do go back and watch that episode 8 again, if you need a refresh. And so, we can now have some fun with other platform ideas. Why not try making long, thin, rotating platforms, and change the direction of rotation like so? Yeah, this is looking fun. The way surfaces move and the player can slide or wall jump off them is so cool. How about we make an interesting container shape? Stuff it on the same scene and make it rotate faster. Oh my gosh, that's manic. How can we even interact with this? I feel like if I time it right, I might be able to jump inside. Yeah, and I'm in. The collisions are working really well. And I wonder if I'll get squashed if, yep, deadly. So next I'm thinking what this rotating container would be like on scene 2 instead. Gotta time this right too. Now these spikes are really awkward. Oh man, come on! Yeah! That was so cool. Question is, can I get back? No, I can't. You know, the best way of coming up with ideas for amazing levels is to do this kind of thing. Just try placing things in a scene and playtest it to see what's fun. You never know what will come out of it until you give it a go. It's such a laugh, and my best ideas come out of just playtesting like this. And on that note, we are drawing to an end, but oh my gosh, I can hardly contain my excitement to see how you guys make use of these new platforms in your Scratch games. As always, there's a link to the Scratch Studio in the video description below. Submit your projects, and myself or curator will add it to the studio. I hope you've enjoyed today's episode. If you did, then smash that like button and don't forget to subscribe to the channel so as not to miss my next exciting tutorial. If you're a tutor or a dedicated fan, then you might consider joining the channel membership to help support the channel further. Plus you get some epic perks like priority replies to comments, early access to videos, or the projects themselves, and of course, those super channel emoji. Gotta love them. Right, that's it from me. Thanks for watching, have a great week ahead, and scratch on, guys!